Hello and welcome to System Analysis and Design class SCSD 2613 for this semester. Okay, we will start with our first slide, part 1, Fundamentals of System Analysis and Design. In part 1, we will cover two main things: organization impact on information system and types of information systems. By the end of this lecture, you will be able to 1. Recall the basic types of computer-based systems that a system analyst needs to address. 2. Understand how users working in context with new technologies change the dynamics of a system. 3. Realize what the many roles of the system analyst are. 4. Know the steps of the SDLC as they relate to HCI and how to apply them to a real system. 5. Understand what case tools are and how they help a system analyst. 6. Explore other methodologies such as object-oriented system design and prototyping. Now we're going to talk about informations. Why is it is a key resource towards organizations? Information fuels business and can be the critical factor in determining the success or failure of a business. It needs to be managed correctly. Managing computer-generated information differs from handling manually produced data. So, what is information system? According to Buckingham et al., 1987, information system is a system which assembles, stores, processes, and delivers information relevant to an organization in such a way that the information is accessible and useful to those who wish to use it, including managers, staff, clients, and citizens. An IS is human activity, social systems, which may or may not involve the use of computer systems. If you look on the right here, there are several components that are important towards information systems. We have people, networking, communications, informations, data, hardware, technology, and also software. What is it and why we need to learn system analysis and design? System analysis and design is a systematic approach to identifying problems, opportunities, and objectives, analyzing the information flows in organizations, and most importantly, designing computerized, in our case, information systems in order to solve a particular problems. System development needs proper planning and there is cost involved. It is time consuming and needs project management. System analysis design is about problem solving that needs to be creative, critical, and innovative. Organization as systems. Organization as systems is composed of subsystems and so on. It is mainly involves level of management and culture. This will impact the information system development. The different levels of management will produce the different level of decisions. The culture influences the way people in the subsystem interrelates. As you can see in the figure, both student affair and faculty subsystem have output and input between themselves. This is done in order to achieve the goal set by the respective system. These figures explain the main component of a system, information systems, and automated information systems. There are 6 generic components in a system: boundary, input, control, processing, feedback, and output. Information systems include the 6 generic components of a system plus data, people, and procedures. Automated information systems include 6 generic components of a system plus the component of information systems plus hardware and software. This figure shows the level of management in organizations. The strategic management responsible for what that needs to be implemented. The tactical management responsible for how it's going to be implemented. The operations management responsible for the implementations itself. These slides provide a definition of system, information system, subsystem, and supersystem. System is a collection of interrelated components that function together to achieve some outcome. Information system is a collection of interrelated components that collect, process, store, and provide as output the information needed to complete business tasks. Subsystem is a system that is part of a larger system, and supersystem is a larger system that contains other systems. If you see on the right here, customer support systems. In customer support system, it have 4 subsystems: customer maintenance subsystems, catalog maintenance subsystem, order entry subsystem, and order fulfillment subsystem. This customer support system, along with manufacturing systems and inventory management system, is part of what we call as a production system, which is a super system. This slide shows the framework for information systems. We have 4 main players: the technology drivers, the business drivers, the players, and the process. The players consist of system analysts and project managers. We have system builders, system designers, system users, and system owners. The process consists of project and process management. It contains system initiations, system analysis, system design, and system implementations. The combination of these 4 produces the product, which is the information system itself. We have a few here. We have transaction processing systems, we have management information systems, we have decision support systems, executive information systems, expert systems, communication and collaboration systems, and office automation systems. There are 12 business drivers for today's information systems: the globalization of the economy, electronic commerce and business, security and privacy, collaboration and partnership, knowledge asset management, continuous improvement and total quality management, business process redesign, networks and the internet, mobile and wireless technologies, object technologies, collaborative technologies, and enterprise applications. Next, major topics in system analysis and design that we need to learn include fundamentals of different kinds of information systems, roles of system analysts, phases in systems development life cycles as they relate to human-computer interactions factors, and computer-aided software engineering case tools. As I mentioned in the previous slides, there are many types of systems in IS. System analysts recommend, design, and maintain many types of systems for users. It includes transaction processing systems, office automation systems, knowledge work systems, management information systems, decision support systems, expert systems, executive support systems, group decision support systems, and computer-supported collaborative work systems. There are many levels in an organization. We have strategic level, we have higher level, we have knowledge level, and we have operational level. Each of these levels have their own systems. A systems analyst may be involved with any or all of these systems at each organizational level. In operational level, we have transaction processing systems. This system processes large amount of data for routine business transactions. It is boundary spanning. It supports the day-to-day operations of the company, for example, payroll processing and inventory management. This slide shows an example of a payroll transaction processing system. A TPS for payroll processing captures employee payment transaction data, such as a time card. Then, the system outputs include online and hard copy reports for management and employee paychecks. In the knowledge level, we have two main systems. The first one is the office automation systems. It supports data workers who share information but do not usually create new knowledge. For examples, word processing, spreadsheet, desktop publishing, electronic scheduling, communication through voicemail, email, and video conferencing. The second one is knowledge work system. It supports professional workers such as scientists, engineers, and doctors. For example, computer-aided design systems, virtual reality systems, and investment workstations. At the higher level, we have three main systems. The first one is Management Information System. It supports a broad spectrum of organizational tasks, including decision analysis and decision making. For example, profit margin by sales region and expenses versus budget. The second system is Decision Support System. Aids decision makers in the making of the decisions. For examples, financial planning with what-if analysis and budgeting with modeling. The third one is Expert System. It captures and uses the knowledge of an expert for solving a particular problem, which leads to a conclusion or recommendations. For example, MyScenes and XCOM. This slide shows an example of Management Information System. If you can see here, we have Transaction Processing System, which is available at the operational level. This system consists of Order and Processing System, Material Resource Planning System, and General Ledger System. The Management Information Systems take all the output from these three systems in the TPS and then convert the data into sales, unique product cost, product change, and expense. And then it will generate a reports and provide online display and dashboard towards the managers. This slide shows the example of a decision support system. In this example, the analytical model database takes 5 main data. The ship file, for example, the speed or capacity, the port distance restriction file, fuel consumption file, ship charter hire history cost file, and port expense file. The analytical model database then will be processed by PC and it will be available for online queries. At the top, we have three main strategic level systems. The first one is Executive Support System. It helps executives to make unstructured strategic decisions in an informed way. For example, drill down analysis and status access. The second system is Group Decision Support System. It permits group members to interact with electronic supports, for example, email and Google Doc. The third system is a computer-supported collaborative work system. It is a more general term of group decision support system. It may include software support called groupware for team collaboration via network computers. For example, video conferencing and web survey system. Next, we will learn about integrating new technologies into traditional systems. We have 5 main components: e-commerce and web systems, enterprise resource planning systems, wireless systems, open source software, and the need for systems analysis and design. Enterprise Application Architecture. Enterprise applications automate processes that span multiple business functions and organizational levels and may extend outside the organization. As you can see in the figure, we have 4 functional areas: sales and marketing, manufacturing and production, finance and accounting, human resource. Enterprise applications comprise of all these 4 functional areas, and it also can extend outside the organizations, such as suppliers, business partners, and customers, distributors. It also can span throughout organization levels, from bottom and to the top. As a system analyst, you need to be aware that integrating technologies affects all types of systems. In the figure, the example given such as wireless systems, ERP systems, and e-commerce and web systems. In e-commerce and web systems, there are many benefits when using it, such as increasing user awareness of the availability of a service, product, industry, person or group, the possibility of 24-hour access, creating a system that can extend globally rather than remain local, thus reaching people in remote location without worry of the time zone which they are located, and then improving the usefulness and usability of interface design. What is Enterprise Resource Planning System? It performs integration of many information systems existing on different management levels and within different functions. For example, SAP and Oracle. In wireless systems, system analysts may be asked to design standard or wireless communication networks that integrate voice, video, and email into organizational intranets or industry extranets. System analysts may also be asked to develop intelligent agents, for example, Microsoft's new software based on Bayesian statistics. Wireless communications is referred as m-commerce or mobile commerce. What is open source software? It is an alternative of traditional software development where proprietary code is hidden from the users. Open source software is free to distribute, share, and modify. It can be characterized as a philosophy rather than simply the process of creating new software. Famous examples of open source software including Linux operating systems, Apache Web Server, and Mozilla Firefox web browser.